All right, the next set of directions say solve for the indicated values. Each diagram features a tangent. So another way that we could say this is that if a line appears to be tangent, you can assume that it's tangent. And so remember that a tangent line touches the circle one time and it creates a right angle with the radius. So this line appears to be tangent, so I get to add a 90-degree angle right here, and then this line appears to be tangent as well. And so I have a theorem that talks about, I have a few different tangent theorems. And so now what we have on top of this shape is we have a quadrilateral with this radius, and we know that a quadrilateral adds up to 360 degrees. And so what we can do is 360 minus 90, which means that this central angle, 110, is going to be supplementary or add up to 180 with this question mark angle. So in order to find the yellow one, I can do 180 minus 110, and that is going to give me 70 degrees left for this question mark angle. We know that those are not the same size, those are not congruent. This angle that's yellow is acute, the other angle is obtuse, and so we would not set those equal to each other. In number 4, it says assume that this line that appears to be tangent is in fact tangent, so we get to add a 90-degree angle. Now what shape do I have on this circle? I've got a triangle. We know that a triangle has an interior angle sum of 180, and so we can do 180 minus 90 minus 36, and that is going to give me 54 degrees, 54-degree angle for x. In number 5, we have two lines that appear to be tangent coming out of the same point. In my class, I call this the ice cream cone theorem. We can assume that the left side of the cone from point A to D, that is tangent, and then, so there's a 90-degree angle, and then C to B, we can put a 90-degree angle here. The left side of the cone is going to be the same as the right side of the cone whenever you have two tangent lines coming out of the same point to a circle. So I can set x plus 4 equal to 19, so we end up getting x equals 15. Okay, if you plugged in 15, you'd get a to b would be 19 and a to d would be 19. So I picture this like a scoop of ice cream, and then we have each side of the cone is the same distance to that scoop. Number 6, we have that exact same theorem again. From point A to D is tangent. So I get to create a radius, and that's angle D is 90. Angle B is going to be a right angle as well. And we know that the left side of the cone, A to B, is going to be the same distance as A to D since those are both tangent lines. So I can take 5x minus 8, and I can set it equal to 2x plus 7. And so we'd get 3x equals 15. So x would be equal to 5. Then they want to know what is A to B. So you want to go back and actually plug that in. That's going to be 2 times 5 plus 7. That's going to be 17. If you want to make sure you did it right, check yourself before you wreck yourself. Plug in a 5 on this side as well. 5 times 5 is 25 minus 8 is also 17. So you'd know that you did it right. All right, number 8 has a bunch of different, we have all these points outside of the circle that we have tangent lines to the circle. So both of these purple amounts will be the same. So I can put an 8 on this side as well. The 3 to the circle will be the same length as this one, so 3 and 3. And then we have 17 and another 17 right here. And then this 7 blue amount to this point will be the same length as that point to the circle on this side. So if we wanted to find the perimeter, we're just going to add all the way around this shape. We're going to add all of those numbers together. And so when we do that, we're going to get 70 millimeters. 70 would be all of those numbers added together. That would be the 3 plus the 3 plus 8 and 8 plus 17 plus 17 plus 7 and 7. And that has a total sum of 70. All right, number 9 is very similar to our previous problem. So I'm going to color code A to W as a tangent line. So A to Z should be the same length. It's also going to be 9. Z to D is going to be the same length as D to Y, so both of those are going to be 3. Y to C is 2, so C to X should also be 2. And then W to B, that tangent line is 5, and so this part of the segment will also be 5. So we want to find the perimeter, so we're going to add all of those pieces together. When we do that, we get a total of 38 inches. So that is all of my pieces added together. 2 of the yellows, 2 of the blues, 2 of the greens, and 2 of the pinks. And those are my tangent problems. That was for 3 through 9. Now the next set says, instead of saying that assume that they're tangent, it says determine if they're tangent. So determine whether the following segments are tangent to the circle, meaning do they create a 90-degree angle at point A? And I'm going to put a question mark there because we are not sure. There's a theorem that helps you to figure out if three pieces make a right triangle, an acute triangle, or an obtuse triangle, and that is the Pythagorean theorem. And so we're going to see if a squared plus b squared is in fact equal to c squared, then it is a right triangle, and then that line would be tangent. If a squared plus b squared is greater than or less than c squared, then it's not going to be a tangent line. So what is my hypotenuse? The hypotenuse is the 20. So you're going to see if 12 squared plus 16 squared, if that is equal to or not equal to 20 squared. So when you do that, I believe you get 400. And then 20 squared is also 400, so that is in fact equal. And so since that is equal, that means that this is going to be a tangent line. To determine whether it's tangent, we would say yes, it is tangent. That is a right angle. Okay. Number 11, we are looking to see if this is a right angle, so I'm going to put a question mark here. Which one is my hypotenuse? My hypotenuse on this right triangle, this possible right triangle, I should say, would be the 19. So we're going to see, is a squared plus b squared equal to c squared or not equal to c squared? So 11.3 squared plus 15.2 squared. We're going to see how that compares to 19 squared. 19 squared. Cannot do that in my head, so hold on one second. 11.3 squared plus 15.2 squared is going to give me 358.72. When you do, that is a horrible 9, sorry y'all. When you do 19 squared, you're going to get 360 something, 9 times 9, so 61. 19 squared is 361. So those are not equal. 358.72 is not equal to 361. And so is this tangent? This is not going to be a tangent line. So this would be a no. This is not a tangent line, meaning that this is not a right angle and this line right here is not tangent. All right, I will start a new video for the back problems.